Good morning, Professor. I'm Wong from Diploma Financial Projects. Today I will talk about the development of prototype battery cooling rig for small-scale EV. EV is a vehicle that using electric as their powertrain. Usually they will be using lithium-ion battery as their main source of power due to the performance and the reliability of the battery. However, it will have some problems like heat generation by the chemical reactions inside the battery. The heat generations will caused by the internal resistance and the exothermic reactions, which release the heat into the surroundings. And the heat generations also will leading to the premature failure to the battery pack, which is increase the aging process, and also will lead to overheat and trigger the chain effect of thermal runaway, and also will degrade the performance of the battery. So that's why the BTMS is developed. What is BTMS? BTMS is battery thermal management system. It's a system that's used to manage the temperature of the battery. It will usually using in the EV or the energy storage system, working as the thermal regulator. You have three types of BTMS, which is active, passive, and hybrid methods. The role of BTMS is used to regulate the temperature range within the safety range, which is about 20 degrees Celsius to 40 degrees Celsius. And it will ensure the uniform of battery temperature is not over 5 degrees Celsius to prevent the thermal runaway. And it also can enhance the performance and durability and the safety. So, why the thermal management is critical? We can divide it into three categories, which is safety, performance, and durability. In safety, the thermal management can ensure the temperature is not over 50 degrees Celsius. If the temperature is over 50 degrees Celsius, so it may increase the chance to trigger the thermal runaway. So it also can ensure the uniform temperature distributions of the battery. As a result, fire and explosions will happen. In performance and durability, due to the thermal measurements, it ensures the temperature is in the optimal operations, which is 20 degrees Celsius to 40 degrees Celsius. So it won't increase the degradations of the battery. As a result, the energy density and the battery capacity won't fading out, and the accelerate of the aging process won't happen. So it can extend the battery cycle life. So in the literature review, we'll find some review about the battery properties and the heat generations to find how the temperature will affect the battery performance. And the BTMS development and PCM cooling will be fine for how to design, how to develop, and how to enhance the PCM performance, because this project will using the PCM. So just like I said, the BTMS have three types, which is active, passive, and hybrids. In active BTMS, it had air cooling method and liquid cooling method. In air cooling method, it have natural convections and forced convections. Usually we will be using forced convections, even though it will need to use extra energy power, because air have a characteristics of low heat transfer coefficients. That's why we'll be using forced convections. And the performance will affect by the directions, the flow rate, and the battery distance. Usually it will affect by the designs. In liquid cooling method, you have direct convections, indirect convections. In direct convections, the direct convections is called as immerse cooling. It will immerse the battery cell into the coolant. And in direct convections, it will be using the cold plate or the cooling jackets to transfer the coolant. Usually the liquid cooling methods will be widely using in the EV, because the coolant have highest specific heat capacities. It also seems like the air cooling method, the performance will affect by the design, how the flow directions the max flow rate and the channel. And both of them have two types of flow, which is reciprocating flow, which is flowing through both way, and unidirectional flow, flowing through one way. In passive BDMS, it has PCM and heat pipe cooling method. In heat pipe cooling method, there are several types of heat pipe, which is tubular, flat, oscillating, and looped. And the characteristic of heat pipe have high thermal conductivity and constant temperature characteristic, and so on. However, the heat pipe is hard to uniform the temperature of the battery, so usually it will be combining with the active BDMS to develop to hybrid versions. In PCM cooling methods, the PCM usually will be using the organic PCM, which is paraffin wax. It has the high latent heat capacity, good thermal cycling, and chemical stability. But the PCM have low thermal conductivity, so usually the engineer will adding the thermal conductivity enhancer or composite. Usually will be reduced graphene oxide, expanded graphite, and metal foam to increase the thermal conductivity. And this the comparative analysis of BDMS. It shows each type of BDMS thermal performance, temperature uniformity, key advantage, and their limitations. Usually the hybrid versions will be widely using in the EV and the energy storage systems due to the temperature control, and the uniformity is very excellent. However, the design of the hybrid versions is very complex and is also very expensive. Okay, so what's the current issues and the problem statements? This project will focusing on small scale EV. So the limitations in the EV is it only has limited space and cost, so it doesn't have any advanced BDMS. Usually the battery in the small scale EV is only just a battery pack. The cooling method is just using natural air without any BDMS. Okay, so it not suitable for high load and continuous operations because it doesn't have any advanced BDMS, so it might have some safety risks. So it may trigger the overheat, thermal runaway, so it may cause the fire and explosions. What about the performance? Because the heat generated during the charging and discharge process, so as a result, the degradations will be accelerated and reduce the battery lifespans. So that's why we'll be doing this project, which is develop the prototype battery cooling rig for small scale EV. So this will be the design proposal. So in design 1, it only have the lithium-ion battery and the PCM. Mr. Shojan said if the lab have extra heat pipe, we can use it in the design 1. And in design 2, it's same as the design 1, but it will adding the heat spreader or the heat sinks. So the conclusions we will need to design and fabricate the battery cooling rig and doing the experiment to test and evaluate the cooling performance of the battery cooling rig. And this is the reference. Thank you.